All right, welcome. We're doing a quick explainer on using Python for data science. We're going to see how you can take a whole mountain of data and get some clear answers from it. So yeah, let's just jump right in.
Okay, just imagine this. Someone gives you a huge file, and it's full of thousands, maybe even more, student scores. And it's your job to make sense of it all. I mean, with that much data, where do you even start? So, first things first, storing the data. You see, before we can even think about analyzing anything, we have to get all those scores organized. We need to put them in a good container, what we in programming call a collection. Now, one option is to use a simple Python list. It's really straightforward. It works just like, a shopping list. You can see it right here. We just list out the numbers, one after the other. Easy enough, right? Well, here's the catch. A simple list is okay for a few scores, but it gets really slow when you're dealing with thousands or millions of them. It just wasn't built for that kind of heavy lifting. And this is where a much better tool comes into play, the NumPy array. You can think of it like a super-powered list. It's designed from the ground up to be incredibly fast and efficient, especially with huge sets of numbers. It packs everything tightly together, so your computer can just fly through it. Okay, next up, finding key information. So we've stored our data in a really efficient way. But how do we find the specific things we're looking for? Let's have a look at how we can search and filter through it all. So one way to do it is the long way. We could write some code to go through every single score, one by one, checking if it's over 90. I mean, it works, but that's like trying to find a specific book in a library by pulling out every single book and checking the cover. But come on, that manual way is just too slow, and you end up writing a lot of code. Instead, we can use another amazing library called Pandas. And Pandas lets us ask questions about our data in a much more direct way. And honestly, this is where the magic happens. Just look at this. With one single clean line of code, we're basically telling Python, hey, just give me all the scores that are greater than 90. It's fast, it's clean, and it's so much easier to understand. Now for our third step, aggregation. Okay, so we've stored the data, we've filtered it to find what we want, but what if we need to see the big picture? Well, aggregation is all about summarizing our data to find those key takeaways. And you know what? The Pandas library makes this so easy, it's almost funny. You want the average score? You just use mean. You want the highest score? You use max. This table shows some of the most common ones. They're just simple words for some really powerful calculations. And what's really powerful is that we can do more than just get one summary for all the scores. We can tell Pandas to first group the data, let's say by classroom, and then calculate the average for each of those groups separately. Now that is how you start to find some real insights. So let's put it all together now. We've seen how these three big ideas can take us from just a jumble of numbers to some really clear answers. Let's do a quick recap. So first, we used a collection, that super fast NumPy array, to store our data properly. Second, we used an algorithm, the Pandas filter, to search for just the scores we were interested in. And third, we used aggregation, like that Pandas mean function, to summarize the data and actually understand it. This simple three-step process of using collections, algorithms, and aggregation is really a fundamental part of data science. In fact, this whole structure we've walked through is based on a university lecture from Dr. Mohammed M. Inuwa, which just goes to show how central these ideas really are. So there you have it. You now have the basic building blocks. You can take a huge amount of data, store it right, find what you need, and then summarize it to get real answers. The only question left is, what complex problem are you going to solve first?